Erica Carlson, a theoretical physicist at the Purdue Quantum Science and Engineering Institute. Today I want to talk to you about measurements and what those are like in quantum mechanics. You've probably taken a lot of measurements in your life. Maybe you thought you had a fever and so you used one of these in order to take your temperature. Maybe you needed to ship a box and so you used something like this to measure the size of the box. Or maybe you've done this. Each of these are measurements. Now, scientists use measurements in order to quantify the world around us. We want to understand how it works, and so we make observations. When we take a specific measurement, now we're getting a number back with units, and then we can compare that to equations we have that predict what we should have found. So, for example, when you took your temperature, you got back a number with units. Maybe you found it was 101 degrees Fahrenheit. When you measured the size of the box, maybe you saw it was 25 centimeters. You got back a number with units. Even when you did this and took a photo, you got back a file. And if you look inside the file, there's a bunch of numbers there, the units there being R, G, and B channels. Now, when we go to take measurements in quantum mechanics, we actually often find that the act of taking a measurement causes a big disturbance on what we're measuring. This is weird because you don't expect this one to happen, right? You don't expect that just because you took your temperature, now you have a fever. You don't expect that the measurement device caused your fever. You don't expect that the act of taking a photo will cause everything to suddenly rearrange. And yet it seems that when we take measurements in quantum mechanics, those kinds of effects are coming to the forefront. Now, maybe you have had a suspicion, like me though, that when you step on the scale, those extra 5 pounds must be due to the scale, right? They have nothing whatsoever to do with the jars of hazelnut spread that we saw in the last episode. Sadly, it's probably just the hazelnut spread, right? Now, when we go to take measurements in quantum mechanics, we often find that there's a change in the system as a result of the measurement. So unfortunately, we're not getting an answer that corresponds to the state of the system before the measurement. Rather, the act of measuring changes the system. Now we get a number out with units, and that's now true of the future state of the system after the measurement. Now, it turns out that this effect actually happens in all measurements. It's just a much bigger deal in quantum mechanics than you're used to. Think about taking your temperature. In order for me to measure my temperature, I had to impart some heat to the device so that it could register it. That actually lowered my temperature a little bit. It's just such a tiny amount that this device can't even measure the difference. Maybe you would think that the act of measuring a box or taking a photo doesn't cause a change. Well, in order for you to measure the box, there has to be light shining on it, or maybe you have to feel it. You got to disturb it in some way. Even taking the photo required that there was some light hitting the object. When the light comes in to hit the object, it bounces off. That's causing a little bit of disturbance to the system. It's just that in these cases, it's such a tiny effect, we say that it doesn't matter. But think about what it would be like to take measurements in the quantum realm. Now we're thinking of shrinking ourselves down to a very tiny size, kind of like Ant-Man. Now when we go to measure things, now we see that the disturbances matter. If you have read about quantum mechanics, or especially have read about philosophy of quantum mechanics, you probably heard this called observer determines reality. Now, this is a technical phrase that we use in quantum mechanics. However, it has a very specific technical meaning to physicists, and it sounds rather different when you pull the phrase out of its context. I prefer to say that observers disturb what they measure. That is a little bit more accurate representation. Here's what we don't mean. We don't mean that the act of measuring means that we can actually control outcomes. We actually don't control outcomes. We don't create new realities by taking measurements. So if you were hoping to watch these videos to find out how to create your own reality, I'm sorry to disappoint you. It doesn't work that way. We don't have control over the outcomes. The outcomes are just whatever they are. If we could create our own realities using quantum mechanics, we physicists would all be driving little red sports cars with great sound systems and That's not the case, sadly. So you know that we're not really able to create our own reality using this method. Now, another thing that plays into this is something called wave function collapse. So next time, we'll discuss the wave nature and how that plays into these measurements that are being taken in quantum mechanics. I'll see you then.